So let us discuss the NEET 2020 question paper. I am going to discuss the physics question paper, 4th H1. The first question is: light of frequency 1.5 times the threshold frequency is incident on a photosensitive material. What will be the photoelectric current if the frequency is half and the intensity is double? So we know that the photoelectric current does not depend on the intensity. There is no effect. So what is the effect of what is the effect of frequency on the photoelectric current? Now you see that the incident light frequency in the first case is 1.5 times the threshold frequency. So as the incident light frequency is greater than the threshold frequency, there will be photocurrent. In the second case, the frequency is half, that means 0.75 times the threshold frequency. As the frequency of the incident light is less than the threshold frequency, therefore there will be no photocurrent. The option corresponding to the first question will be 1. Second question: a long solenoid of 50 cm length having 100 turns carries a current of 2.5 amperes. The magnetic field at the center of the solenoid. So we know the magnetic field at the center of the solenoid is given by B is equal to mu naught N I, where N is the number of turns per unit length. So B is equal to mu naught into N by L into I. So mu naught is given to be 4 pi into 10 power minus 7, and number of turns to be 100, and the length 50 centimeter, that is 50 into 10 power minus 2 meter, and current I is 2.5. Solving this, we are going to get 6.28 into 10 power minus 4 Pascal. So the option for this is second option. The third question: for which one of the following Bohr model is not valid? So from the options we can say that Bohr's model is applicable only for singly ionized hydrogen atom. So the option 1 is not a singly ionized hydrogen atom. So the correct answer is that first option. A short electric dipole has a dipole moment of 16 into 10 power minus 9 coulomb meter. The electric potential due to a dipole at a distance of 0.6 meter from the center of the dipole, situated on a line making an angle of 60 degrees with the dipole axis. Potential due to a dipole at a general point is given by V is equal to Kp cos theta by r square. So the value of K is given by 1 by 4 pi epsilon, that is nothing but 9 into 10 power 9, and P is the dipole moment, which is going to be 16 into 10 power minus 9, and cos theta. Theta is the angle between the P vector and R vector, that is going to be 60 degrees, so that cos 60, and r square, that is the distance between the center of the dipole and the point where the electric field the potential due to the dipole is required, that is given to be 0.6 meter. So solving this, we are going to get 200 volt. So the option corresponding to this will be let us discuss question number 5. The capacitance of a parallel capacitor with air as medium is 6 microfarad. So C is equal to 6 microfarad. With the introduction of a dielectric medium, the capacitance becomes 30 microfarad. So C dash is equal to 30 microfarad. But C dash is also equal to K into C, where K is the dielectric constant, and this K is also again equal to epsilon by epsilon naught. Therefore, into C. So applies 30 microwave is equal to epsilon by epsilon naught into C is given to 6 micro. 6 micro gets cancelled 6 pi. So epsilon is equal to 5 epsilon naught. The epsilon naught value is 5 into the actual 8.85 into 10 power minus 2. So solving this, we are going to get 0.44 into 10 power minus 10 Coulomb square per meter square. So this is the value of epsilon, and the option corresponding to it will be 4. Light with an average flux of 20 watt per centimeter square falls on a non-reflecting surface at normal incidence having surface area 20 centimeters square. The energy received by the surface during time span of 1 minute is. So, energy is equal to intensity multiplied by area multiplied by time. So here intensity is given by 20 watt per centimeter square. So it will be, maybe writing here, 20 watt per centimeter square, area 20 centimeters square, and time is going to be 1 minute, that is 60 seconds. Now centimeter square gets cancelled. So the energy received will be 24 into 10 to the power 3 joule. So the option corresponding to this will be 4. Question number 7. Two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from the 5 kg particle is nearly at a distance of. So this is a two particle system having 5 kg and 10 kg. So the center of mass lies closer to the particle having heavier mass. So this will be the center of mass, and let the distance between the center of mass and 5 kg and 10 kg be R1 and R2, and the total distance, the distance between 5 and 10 be R. Now R1 and R2 will be in the inverse ratio of their masses. So R1 by R2 is equal to M2 by M1, that is 10 by 5. So R1 is equal to 2R2. So I can write down as R1 is equal to 1 by 3. It is 2/3 of R. So that is 2/3 of R. R is given as 1 meter, that is 67 centimeter approximately. So the option corresponding to this one will be 4. Resistance is given below. The value of resistance and tolerance respectively are. So yellow, violet, brown, and then gold. So the color code is being given by, we memorize it as B.B. Roy of Great Britain has very good wife. yellow, 4, violet, 7, and brown, 1, 10 to the power 1, gold, tall price 5%. So the resistance is 47 into 10 power 1, that is 470 ohm, and tolerance is 5%. The answer corresponding to this one, or the option corresponding to this answer is first. Which of the following graph represents the variation of resistivity rho with temperature T for copper? So we know that the resistivity increases non-linearly with temperature. Is a conceptual question, and the graph corresponding to the option number 4. This difference between displacement and acceleration of particle in a simple harmonic motion is pi radian. Again, it is a conceptual question. So it will be the option corresponding between the 2. The solids which have negative temperature coefficient of resistance are insulators and semiconductors. Again, it is a conceptual question. The option corresponding to this answer is first. The quantities of heat required to raise the temperature of two solid copper spheres of radii R1 and R2 such that R1 is equal to 1.5 times of R2 through 1 Kelvin are in the ratio. So we know that the heat required to raise the temperature of any body is given by ms del theta, mass, S is the specific heat of the body, and del theta through which it has to be. Now in this case, it is a copper, so this is also constant, and del theta, both are being raised to the same temperature 1 Kelvin. So Q is proportional to mass, and mass is equal to volume into density. The density is constant, so mass is proportional to volume. So they had given it to be a solid copper sphere, so the volume is proportional to RQ. So Q1 by Q2 is equal to R1 by R2 whole cube. That is equal to R1 is given 1.5 times of R2 by R2 whole cube. So R2 gets cancelled. 1.5 is 15 by 10 whole cube. So it is 5 3s and 5 10. So it will be 27 by 2 cubic. So the answer corresponding, the option corresponding to this answer is. For transistor action, which of the following statements is correct? The base region must be very thin and lightly doped. So definitely the first option is the correct option. The answer to this one is first option. Ball is thrown vertically downward with a velocity of 20 meters per second from the top of a tower. It hits the ground after some time with a velocity of 80 meters per second. The height of the tower is. So this is the tower. And if a person throws it downwards with 20 meters per second and it reaches the ground with a velocity of 80 meters per second, then what is the height of this tower? So as it is thrown downwards, u is equal to minus 20 meters per second, and v is also equal to minus 80 meters per second. The kinematic equation that is required, to find out the height of the tower our case, v square is equal to u square minus 2g. So, v square I square y. So 2gy is equal to u square minus v square. So that is 2 into g 10 y u 20 square minus 80 square. Substitute the signs. Then 2 tens are 20 square and here into 4. Solving this, y is equal to minus 300 meter. So, with respect to this, if I take y equal to 0, here the final equation is y is equal to minus 300. Implies the height of the tower is equal to 300. So, the option corresponding to this answer is first one. Twistor's angle IP for an interface should be. So, we know that mu is equal to tan of IB. So, IB is equal to tan inverse mu. Mu value should be greater than 1. So, the IB value should be greater than 45 degrees. And the tan value is, and it is 90 degrees. So, the option corresponding to this one will be thermal energy of a monoatomic gas is, straight away it is 3 by 2 kBT. The option corresponding to it will be third option. In a certain region of space with volume 0.2 meter cube, the electric potential is found to be 5 volt throughout. The magnitude of electric field in this region is, as we know that E is equal to minus dV by dr. The volume is constant, so the electric field must be 0. So the option corresponding to this one is second option. The body weighs 72 Newton on the surface of the earth, which is equal to 72 Newton. What is the gravitational force on it at a height equal to the half of the radius of the earth? So H is equal to R by 2. So we want to know the gravitational force. So we know that the acceleration due to gravity at H is given by G dash is equal to G by 1 plus H by R whole square. As H is comparable with radius, I will use this formula, that is equal to G by 1 plus R by 2 by R whole square. So it will be 1 plus 1 by 2, that is 3 by 2 whole square, that is equal to 4 by 9G. Now the weight, the gravitational force at the height mg dash is given by m into 4 by 9 of g. But you know mg is equal to 72. So 4 by 9 times of 72 gives you 9x. So for example, so the option corresponding to this one will be third option. In Young's, question number 19, Young's double slit experiment, if the separation between coherent sources is half and the distance of the screen from the coherent sources is doubled, then the fringe width becomes So the separation between the coherent sources is half. So this is half. And the distance of screen from the coherent sources is doubled. So that is 4 times of d by d. So this is the first case and this is the second case. So you can see that the beta has been increased by 4 times. The fringe width increased by 4 times. So option will be 4th option to this question. The energy equivalent of 0.5 gram of a substance is, we know that Einstein's equation, energy equivalence equation, E equal to mc square. So m is, they have given to be 0.5 gram, so conversion in kilograms. So it is 0.5 into 10 power minus 3, and C is 3 into 10 power 8 whole square. So the E value turns out to be 4.5 into 10 to the power 13 joule. So the option corresponding to this answer will be 21. Dimensions of stress. Stress is the restoring force developed per unit area. So dimensions of stress is equal to dimensions of force by dimensions of area. Force is ml power minus 2 and area L square. So it will be ml power minus 1, t power minus 2. So the option corresponding to this will be the first option. A wire of length L, area cross section A, is hanging from a fixed support. The length of the wire changes to L1 when mass M is suspended from its free end. The expression for Young's modulus. So we know that Y is equal to longitudinal stress by longitudinal strain. Stress is the, as we discussed earlier, it is the weight, the restoring force is equal to mg, area is A, so this is the stress, longitudinal strain, that is the change in length by original length. So that is given by mg L by A del. So the initial length is given to be L only. So mgl, the change in length, the new length has become L1 and the initial length is L. So this is the change in length. So this is the Young's modulus. The option corresponding to this answer is first. Question. A series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, the phase difference between current and voltage is pi by 3. If instead C is removed from the circuit, the phase difference is again pi by 3 between current and voltage. The power factor of the circuit is. In the first case, tan theta is equal to xc by r, and theta is given to be 60 degrees. So tan 60 is root 3. So x is equal to root 3 r. This is first. And in the second case, capacitor is given. So tan theta is given by xl by r. So in this case, also the angle between the current and voltage is 60 degrees. So xl is equal to root 3. Now, what is the power factor of the circuit? So there is a So therefore, the circuit is in resonance. The power factor of a circuit which is in resonance is given by 1. So the option corresponding to this one will be 20. Assume that light of wavelength 600 nanometer is coming from a star. The limit of resolution of a telescope whose objective has a diameter of 2 meters. So we know that the limit of resolution of a telescope is given by 1.22 lambda. On substituting lambda is equal to 600 nanometer and d 2 meter, the answer turns out to be 3.66 into 10 to the power minus 7 radian. And d is the diameter of the objective. Option corresponding to it will be second option. The mean quick path for a gas with molecular diameter d and number density n can be expressed as. The formula is 1 by root 2 n pi d square. So the option corresponding to this will be third. 1 by root 2 pi root 2 n pi d square. Further, logic circuit shown that truth table is. So these two are NOT gates which will invert the inputs. So A is given. Here it will be A1 and B will be. Now these two are applied as inputs to this gate, which is an OR gate and above, so it will be a NOR gate. So the output of Y will be A1. So this is the output of the OR gate, and I am having a bubble that is NOR gate. So taking on one slope, I can write it as A1 and so this is equivalent to AND gate. So in AND gate, if any input is low, the output is low. So the truth table corresponding to this equation is option number 2. The ratio of contributions made by the electric and magnetic field components to the intensities of an electromagnetic wave. The contributions are equally made, so the option will be third one, that is 1 is to 1. 28. Two cylinders A and B of equal capacity connected to each other via a stop. A contains an ideal gas at standard temperature and pressure. B is completely vacuum. The entire process is thermally insulated. The stopcock is suddenly opened. The process is adiabatic process. And the option is third. That is an adiabatic process. The energy required to break one bond in DNA is 10 power minus 22. This value in electron volt is nearly. So we know that 1 electron volt is equal to 1.6 into 10 to the power minus 20 joule. So it is asking 10 power minus 20 joule is equal to how many electron volts? This is x. So x is given to be 10 power minus 20 by 1.6 into 10 to the power minus 11. So upon solving this, you are going to get 6 electron volt. So the option corresponding to this one will be 4th. Question number 30. Find the torque toward the origin when a force of 3 j cap Newton acts on a particle whose position vector is 2 k cap meter. So we know that torque tau bar is equal to r bar cross L. So r bar is given by 2 k cap and force F bar is given by 3 j cap. So 2 3s are 6 and k cap cross j cap will be minus 8. So the torque is given by minus 6 I cap Newton meter. Option corresponding to this will be. A screw gauge has least count of 0.01 mm and there are 50 divisions in its circular scale. The pitch of the screw gauge is. We know that least count is equal to pitch by number of circular divisions, number of divisions on the circular scale so pitch is equal to least count times number of divisions. So least count is given by 50 and as the options are in mm, let the least count be now 7.01. So it will be 0.5 mm. This is the pitch. So the answer is 0.5 mm. The option corresponding to this will be. Taking into account the significant years, what is the value of 9.99 minus 0.0099? It will be 9.9801. Rounding off this to 3 digits, it will be 9.98. So the answer corresponding to option corresponding to this answer is question number 33. A spherical conductor of radius 10 cm has a charge of 3.2 into 10 power minus 7 coulomb distributed uniform. What is the magnitude of electric field at a point 15 cm from the center of the sphere? So as the point is outside the sphere, I can say that the whole the charge on the sphere can be supposed to be concentrated at the center, and I can write on formula as E is equal to KQ by R square. So K is 9 into 10 power 9 and the charge is given to be 3.2 into 10 power minus 7 and R is the distance between the center and the point where electric field is desired is 15 centimeter, that is 15 into 10 power minus 2 meter whole square. So solving this, you are going to get 1.28 into 10 power 5 Newton per coulomb. So the option corresponding to this will be third. 34. A charging particle having drift velocity of 7.5 into 10 power minus 4 meter per second in an electric field of 3 into 10 power minus 10 volt per meter has a mobility in meter square per volt per second. So we know that the mobility is given by the drift velocity acquired per unit meter. is 7 point, the drift velocity is 7.5 10 power minus 4 by 3 into 10 power minus 3. Solving this, we are going to get 2.5 into 10 power 6 is meter square per mole per second. So, the option corresponding to this is in a guitar, two strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hz. When tension in B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530 Hz, the frequency of A is 530 Hz. What is the original frequency of B? So the frequency of B will be what? So the frequency of B will be can be 524 Hz or it can be 536 Hz. So when tension in B is slightly decreased, so when tension in B is decreased, then the frequency of the B also decreases. As frequency of B decreases, if that means if this one decreases, the difference between these two increases. If this one increases, the difference between these two decreases. So that is nothing but the beat frequency. So when tension decreases, the frequency decreases. If it is 524, then if it is further decreases, then the beat frequency increases. Now 536, if it decreases, the beat frequency decreases. Whereas in the first case it is increases, second case it is decreases. But in the problem they said it is increases to 7 Hz, so it is increasing. So definitely this should be the answer. So the option corresponding to this answer is third. Nylon rod of susceptibility 599 is subjected to a magnetizing field of 1200 ampere per meter. The permeability of the material of the rod is. We know that mu is equal to mu naught mu r. That is equal to mu naught into I plus 1. So the value of mu naught is 4 pi into 10 power minus 7, whereas I, the susceptibility, is going to be 599 plus 1. So solving this, it turns out to be 2.45 into 10 power minus 4 Tesla meter, and the option corresponding to this answer is the second one. 40 microfarad capacitor is connected to a 200 volt 50 Hz AC supply. The RMS value of the current in the circuit is in nearly. So we know that IRMS is equal to ERMS by XC. That is equal to ERMS into omega C. The supply voltage is 200 volt. That is ERMS. Omega, that is 2 pi. Frequency is 50. And capacitance will be 40 microfarad and 40 into 10 power minus 6. Solving this, you are going to get 2.5. So the option corresponding to this answer is an electron is accelerated from rest to a potential difference of 3 volts If the de Broglie wavelength of the electron is 1.227 into 10 power minus 2 nanometer, the potential difference is. So we know that de Broglie wavelength of an electron is given by lambda is equal to 12.27 by root V angstrom. So root V is equal to 12.27 by lambda angstrom. So 12.27 by lambda is given to be 1.227 into 10 to the power minus 2 nanometer into 10 to the power minus 9 angstrom into 10 to the power minus 10. So solving this one, V turns out to be 10 power 4 ohm. So the option corresponding to this answer is the first. The increase in the width of the depletion region in a PN junction diode is due to increasing forward current. So the increase in the width of the depletion region in a PN junction diode is due to. So a depletion region is formed in an unbiased PN junction diode. So the depletion region decreases when it is forward biased and it increases when it is reverse biased. So the option corresponding to this one will be 39 when the diode is reverse biased. When a uranium isotope is bombarded with a neutron, it generates krypton, 3 neutrons end. So the nuclear reaction uranium 23592 is bombarded with a neutron. It generates a krypton 89, 36 and 3 neutrons. You don't know what is the other thing. Now, in a nuclear reaction, charge as well as mass number are cancelled. So, 92 is equal to 36 plus Q. So, Q is equal to 56 and mass number 235 plus 1 is equal to 89 plus 3 plus P. Solving this, P is equal to 170. So, it is X is nothing but having X mass number 144, doubling number 56. This is nothing but barium, and the option corresponding to this will be second. Question number 40. A capillary tube of radius R is immersed in water, and water rises to a height h. The mass of the water in the capillary is 5 grams. Another capillary tube of radius 2r is immersed in water. The mass of water that will rise in this tube. So, we know that the weight of the liquid in the tube is balanced by P cos theta into 2 pi r, where r is the radius of the capillary tube is equal to m. Now here r and m are proportional to each other, so m is proportional to r. So now the radius is doubled, so the mass also gets doubled, so the answer will be 10 grams. So the option corresponding to this will be question number 42. Two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless. The acceleration of the system in terms of acceleration due to gravity. So this is an active machine. The acceleration is given by m1 minus m2 by m1 plus m2 into g. m1 is equal to 6 and m2 is 4. 6 minus 4 by 6 plus 4. 6 minus 4, 2. 2 5 7. A ray of question number 43. A ray is incident at an angle of incidence I on one surface of small angle prism with angle of prism A and emerges normally from the opposite surface. If the refractive index of the material of the prism is mu, then the angle of incidence is nearly equal to. So, this is a small angle prism having angle of prism as A. If a light ray is incident like this, and he says that after refraction it is incident in such a way that it emerges normally from the opposite surface. So here the angle of refraction is 0 and also the angle of incidence here R2 is equal to. We know that R1 plus R2 is equal to. As R2 is equal to 0, R1 is equal to 8. Apply the Snell's law at this surface. It will be mu is equal to sin n by sin r. That is I sin I is equal to mu times of sin r. That is equal to, here the angle of refraction will be R1, so it will be mu sin A. The small line is I is equal to mu A. So the option corresponding to this will be fourth option. Cylinder contains hydrogen gas at pressure 249 kilopascal and temperature 27 degrees Celsius. Its density is. So density rho is equal to Pn by R. Where P is the pressure and the molecular weight, R is the universal gas constant, and T is the temperature. So substituting P is equal to 249 kilopascal, that is 249 into 10 power minus 3, and molecular weight is 2 gram, that is 2 into 10 power minus 3, by R is given by 8.3 and it is kilopascal, so it will be 8.3 and the temperature is 27 degrees Celsius, converting into Kelvin and Kelvin. Solving this, you are going to get as 0.2, density is given to 0.2 kg per meter. A resistance wire connected in the left gap of meter bridge balances a 10 ohm resistance in the right gap at a point which divides the bridge wire with a ratio P is to 2. If the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire is. Here, unknown resistance X has been connected, and here 10 ohm, and jockey is like this. So this jockey divides the potentiometer, the mid-bridge wire in the ratio 3 is to 2, so this will be 3x and this will be 3x. So I can write on it as, and call it as something 3a, 2a, so the x is that here. So x by 3 is equal to 10 by 2, so 2 twice. So the resistance of the unknown resistance is 15 ohm. So the length of this 15 ohm is 1.5 meter. What will be the length of the 1 ohm resistor? L for L. So L is given by 1.5 to 15. That is equal to 1 into 10 power minus 1 meter. So the option corresponding to this one will be